Alrighty, in this video we are going to be talking about vector value functions. And the term vector is going to be used to indicate a quantity that has both magnitude and direction. We'll use this with PVA problems that you'll see on the exam. But first, some definitions that you'll probably see them as things that we've already saw in AB, but of course we're going to make it in terms of vectors. A vector value function just means that a function with domain of all real numbers, but range is going to be a set of vectors. Is a set of vectors. Now, because this is a vector, the velocity vector is just you saying, okay, x prime of t, y prime of t, and calling it a day. So this is going to be the x position, and this is going to be the y position. Acceleration, plot twist, x double prime, y double prime. Magnitude and speed. So this is going to be velocity. And remember that this is magnitude, so don't confuse it with absolute value bars. So this is going to be the square root of dx dt square plus dy dt square. Direction, that's going to be the velocity vector, so v of t over the speed. So velocity vector over speed, just in case you need it. And then distance traveled is going to be the integral from a to b of the magnitude slash speed. So that's going to be that. And of course, that's just going to be the same thing as the arc length formula. So the integral from a to b of dx dt square plus dy dt square. So anytime you're finding magnitude or speed, it's going to be very similar to distance traveled, except distance traveled, of course, you're taking the integral of it. All right. Number one, we have a particle moving along a curve in the xy plane so that its position x of t, y of t at time t for t is greater than or equal to 0 is this lovely thing right here. Part A says find the velocity vector and the acceleration vector at time t is equal to 1. So to do this, you are just going to go ahead and take the velocity, aka the derivative, of both x and y. So negative 3t squared plus 4 plus e to the t. That's your x component. Your y component is just 2t minus 1. And you're going to call it a day. Of course, it tells you to find the velocity vector at t is equal to 1. So you're just going to evaluate that at 1. Negative 3 plus 4 plus e, comma, 2 minus 1, or 1. This can be simplified down to 1 plus e, 1. Boom. The acceleration vector, that's just me taking the second derivative, or v prime of t. So that's just going to be negative 6t plus e to the t, and then 2. There you go. Let me make sure that that doesn't confuse you. There you go. And then we're going to find the acceleration vector at time t is equal to 1. So that's going to be negative 6 plus e, and then 2 being your y component. All right. Part B says find the speed of the particle at t is equal to 3. So speed is going to be the square root of the x component of the derivative, and then the y components of the derivative, and then we're squaring them. So, dxdt we saw earlier is this right here, and all you're going to do is just plug in 3 for my component vector. So in this case, at 3, I'm going to get -3, 3 squared plus 4 plus e to the third. This is 9. 9 times -3 is -27. Plus 4 is -23. Plus e to the third. Now, my y component at t is equal to 3 is just me saying 2, 3 minus 1, which is just 5. All right, so now we have -23 plus e to the third square plus 5 square, or 25. Since this is in a calculator inactive problem, we're just going to leave it like that and call it a day. That's all we're going to do. If this was a calculator, you can, plug this in and then see what value you get. C says find the equation of the tangent line to the path of the particle at t is equal to 2. Okay, so if t is equal to 2, I am going to figure out what my coordinate is. So to figure that out, I'm just going to plug in 2 for my x and y. So that's my x component. And this is -8. This is +8. That's going to cancel out. So I'm just left with e to the t plus 5. No, sorry, -5. This is a minus sign. So e to the t minus 5. Well, sorry, e to the second power minus 5. That's a 2. So that's my x component. My y component is just 2 squared, which is 4, minus 2, minus 7. 2 minus 7 is -5. So this tells me that at t is equal to 2, my component is e squared minus 5, -5. To find the equation of the tangent line, remember that I need slope, which means that I need dy dx, which means that I need dy dt over dx dt at t is equal to 2. Well, I'm just going to go ahead and cheat my way through and just use my velocity vector right here, then call it a day. At 2, I'm going to get 4. 4 times -3 is -12. -12 plus 4 is going to be -8. Then, of course, you have this. So that's just -8 plus e squared. We're going to do the same thing with dx dt. Oh, wait, sorry, that is x. So there you go. And then dy dt, I'm just going to plug in 2, so that's going to be 4 minus 1 over 3. So this right here represents my derivative at t is equal to 2. And this right here represents my component form. So you are just going to combine everything together and then call it a day. So now I have y plus 5 is equal to 3, -8 plus e squared, x minus e squared minus 5. Pay careful attention to your parentheses because these are together. You want to make sure that they are both in parentheses right here. All right. I guess most of these require a calculator, so I guess I'm going to show you the tips and tricks of using the calculator. Number 2, we have a particle moving along a curve in the xy plane. dx dt is inverse tangent of e to the -t. dy dt is 3t over 1 plus 4t to the third. Now, part A says find the speed of the particle at time t is equal to 1. Now, on the AP exam, if they ask you to find the speed, all you have to do, and whenever it says like justify your work or show your work, all you have to do is just give them the formula and then say that t is equal to 1. So here, what you can do is just say that plus that square, and then that's going to give you the speed. That's your work point, essentially, showing that you know that this is the speed. Well, to find out the value of that, I'm just going to go ahead and go to my handy-dandy calculator and then find the speed. As a trick, I am going to put this in y-vars, just because I'm going to be doing a lot with part B, C, and D for number 2. All right, so for dx/dt, I'm going to put that on y1. That is going to be inverse tangent of e to the negative t. Y2 is going to be 3t over 1 plus 4t to the third, and then we're going to call it a day. All right, so to find the speed, we are going to do the square root of y1 square, y1 so y1 square plus y2 1 square. Hit enter, and that's going to give you 0.6958 as your speed. So 0.69589 as your speed. All right. Part B says find the average speed of the particle over the interval 1 to 4. Whenever we're talking about average speed, we are just going to find the speed, average speed. So that's going to be the integral, 1 over 4 minus 1, times the integral of 1 to 4 of the magnitude of v of t, aka your speed. Now the reason why is we remember that the integral from 1 to 4 of this represents the distance traveled. So if I want the distance traveled over the time period of 1 to 4, I'm going to get my average speed. So in this case, now I have 1/3, since 1 over 4 minus 1 is 1/3. I'm going to be taking the integral from 1 to 4 of y1 square plus y2 square, and then calling it a day. Oops, I forgot to take the square root. Hold up. Go ahead and raise everything to the 1/2. There you go. And that's going to give me 0.2086. That's going to be my average speed of the particle over 1 to 4. Part B says find the distance traveled by the particle over the time interval 1 to 2. So if I'm talking about distance traveled, that's just me doing this right here and then calling it a day. In this case, I'm only doing 1 to 2. I'm not doing anything with the 1/3, so I could take that out, and then I'm going to replace the 4 with a 2. Hit enter. That's going to give us 0.4066. Find the acceleration vector at time t is equal to 1. All right, so using my handy dandy calculator again, remember that what we had on y vars is dxdt and dydt. So to find the acceleration vector, I'm just going to be taking the derivative of y1 at 1, and then I'm going to take the derivative of y2 at 1, and that's going to give me my x and y components of the acceleration vector, because technically y1 and y2, like I said, are already derivatives. So here I'm going to do dx y1 with respect to, y1, then that's going to be x is equal to 1. That's going to give me my acceleration vector for my x component at t is equal to 1. And then if I were to do the same thing for y2, aka my y component, that's going to give me negative 0.8399. So this tells me that my acceleration vector at time t is equal to 1 is going to be negative 0.324, negative 0.3839. Now for for part D here, if you give me this is going to be wrong because there's no supporting work. So you do want supporting work to say that, okay, the acceleration vector is going to be the same thing as you saying x double prime of 1 and y double prime of 1. And that's going to be your little supporting justification work. All right, number 3. A particle moving along the curve in the xy plane is given by the position x of t, y of t at time t for t is greater than or equal to 0, where we have dxdt being ln of t plus 1 and dydt being sine of e to the negative t square. And it also tells me that time 1, the particle is at 2, 5. Part A says find the slope of the tangent line to the curve at the position 2, 5. Okay, so because the curve is at position 2, 5, that means that t is equal to 1. So whenever I'm finding the slope, I'm technically doing dy dx at times equal to 1. And remember that dy dx is going to be the same thing as dy dt over dx dt at time is equal to 1. Well, since this is a calculator active problem, I'm going to go ahead and replace my y1 and y2 to be my new y1 and y2. We have ln of x plus 1 and then we have sine of e to the negative x squared. All right, since they're both derivatives, I could just say y2, 1 over y1, 1. And the reason why, because remember that my second y equals is my dy dt, and then my first y1 is dx dt. So to find the slope, I have dy dt over dx dt. Hit enter, and that's going to give us 0.5188. Part B says find the x-coordinates of the position of the particle at time t is equal to 3. Okay, so we are given the derivative, the velocity. So to find the x-coordinates, I'm going to have to take the integral to get that. Well, notice how at time 1, the position is at 2, 5. So using good old FTC, I'm going to have 2 plus the integral from 1 to 3 of v x of t dt. In this case, that's going to be ln of t plus 1 dt, since I'm only looking at my x-coordinate. In other words, once again, I'm starting at 2 because that's what's happening at times equal to 1. And then I'm going to take the integral from 1 to 3 so that I can find the position at time 3. All right. So once again, using my handy dandy calculator, I'm going to do 2 plus the integral from 1 to 3. And I only want y1 because that is the xdt. So hit enter, and that's going to give me 4.1588. 4.1588. The other problems are going to be very similar. They are self-explanatory. And then after this lesson, it is just going to be practice FRQs on parametric equations with vector value functions. So lots of PVA in terms of parametrics.